next item is subsurface dam. When we say subsurface dam, it means that a dam underground has to be constructed. That would be usually below the bed of the stream. It is a sort of a dike. We can also say it is a sort of a dike. The purpose of the subsurface dam is for preserving the groundwater on the upstream side of the dam. In the case of a watershed development work, we increase the recharged water table and increase the groundwater content in the watershed. This groundwater would find its way into the stream and further down to a lower area at a velocity which would be much less when compared to surface water. The transmissibility coefficient of the geological formations, including the sandy bed in the stream, would determine the rate at which the groundwater flows to the downstream side. In a watershed, even though the groundwater recharge is increased by several means, if it is not utilized within the watershed, it will find its way out, and during the non-monsoon period and especially in summer, whether we use the groundwater or not, the water table levels will fall down and go to a lower level, and this is because it flows out of the watershed. It is therefore necessary to prevent such outflows from the watershed by constructing an appropriate structure. This structure is usually a subsurface dam, the details of which I will explain. The purpose of this is to see that groundwater flow in the subsoils and substrata is arrested by a positive blanket diaphragm. Let us now study the details of a subsurface dam. Supposing this is the stream course, that is the main stream in the watershed, and there are high grounds on either side. At one particular point, we can select that location for construction of a subsurface dam. For bringing down the costs, we can select a place where the width of the stream would be less. This could as well be constructed here, but the width of the stream is much more when compared to this width. And when this subsurface dam is executed, there would be groundwater preserved on the upstream side. This is the upstream side and this is the downstream side. Now a question may arise whether the groundwater which was flowing earlier when the subsurface dam was not there, is it not prevented by such structure? Yes, it gets prevented, the flow gets prevented, and down below people may find a problem when their groundwater flow into that area is reduced. But usually in most of the watersheds, the upstream watershed would be without any big basin draining into it, whereas as we go to the downstream side, number of tributaries for this would be coming and joining, and there would be a bigger basin as we go towards the downstream side, and there would be good amount of groundwater on account of draining a much wider and a bigger basin. That is because in any stream course, as it flows down, the basin gets increased in size and a greater extent of area would get drained into the stream because number of tributaries would be joining, and also the catchment area or the watershed area down below would be going on increasing as one goes further down. But there would be instances when there won't be any such increase in the catchment area, or there won't be any additional tributaries joining, and people may get handicapped or may put to difficulties when the groundwater is not adequate and when the groundwater from upstream side is not reaching them. In such cases, there would be a need for constructing one more subsurface dam on the downstream side to meet such contingency, but such contingencies would be very rare. Now let us see how this stream course looks in sectional elevation. This is the stream bed and this is the surface flow. This is the stream bed and this is the surface flow, and the bedrock profile is something like this, that is sheetrock, and the layer above the sheetrock is all alluvium. It could be fine sand, coarse sand, or it could be clay also in some cases. Lenses of clay could be there, and the groundwater is stored in this alluvium. Now this is the sheet rock, not disintegrated rock or fractured rock or any such thing, but hard sheet rock, what we call fresh rock. That is the profile. Now this is the membrane or the positive blanket cutoff wall, or in other words subsurface dam, which is built from the bed of the stream right up to the bedrock level. By doing geophysical surveys for the area, we can determine economical site for the construction of the subsurface dam. If supposing we know this profile, we won't go in for a subsurface dam here, because the depth of the dam is much more here when compared to the depth of dam here. So we can make a selection of the site which gives the least cost in that topography, in that geological formation, by knowing certain details about the geology at the vicinity where we are going to construct the subsurface dam. So geophysical soundings will have to be taken in the stream course at certain grid intervals, which the geoscientist would be able to determine, and it is possible to determine this profile of bedrock, and also it is possible to get the end connections. For example, the subsurface dam will not be only within the stream, but it has got to be extended on either side till it meets hard rock at a level higher than the bed of the stream. So this I will explain in another sketch. Now thing that has got to be remembered is the four waters concept is having a geoengineering component, and a geophysical study will have to be made by the specialist to work out the most cost effective structure of the subsurface dam. Supposing this is the bed of the stream and this is the bank level and this is the bedrock level. The subsurface dam, as we have seen in the other diagram, extends from the bed level to the rock level. This consists of 0.9 meter thick puddle clay. This puddle clay is nothing but the clay with high plasticity, which is usually available in tank beds very close to the tank bund. The clay that is very close to the tank bund would be with high plasticity, whereas the silt that is away from the tank bund would not be having this plastic clay. It has to be collected from the nearby tank of an old tank at a distance close to the bund where puddle clay is available, and it has to be brought to the site, and after making that into powder, water has to be added into that, and lumps of clay, lumps of puddle clay will have to be carried through manual labor and dumped on the bottom layer, and the consolidation of the puddle clay is only by treading by foot. Just walk on the puddle clay, it gets consolidated. There is no need to apply any rammer. It is just by walking on the puddle clay it gets consolidated. And before this puddle clay is put into this, it is necessary to excavate a trench, usually with this width and a side slope in the sandy bed. The side slope could be something like 2 horizontal to 1 vertical, or 1.5 horizontal to 1 vertical. After excavating this trench, the excavated soil is deposited at a safe distance away from this, and then some centering arrangement will be needed to keep this puddle clay to this section. That centering would be just ordinary wooden sheets, and the puddle clay is having an outer cover of HDP film, high density polyethylene film, on either side of the puddle clay. As seen here, this is one film and this is another film. This film is very small thickness, usually 200 microns. It will be colored black, and this film is intended as an additional safeguard to prevent flow of water from upstream to downstream. Now here 2 films are provided on either side as a safe precaution in ensuring that no water flows through. The real thing that prevents the flow is the puddle clay. The 2 films are in addition to the puddle clay, and as the clay is filled in, then the film also is extended. So like that, the construction work of the puddle clay will be carried on up to the bed level. There is no need to construct any puddle clay wall above the bed level. In fact, it can stop at 6 inches below the bed level, 0.3 meter below the bed level. Let us see how it looks in the plan. This is the plan showing the stream flow, and this is the right bank and this is the left bank. Flow direction is like this. This is the stream width and this is the stream slope, and slope on the other side, and these are all the banks. Now this subsurface dam is constructed within the stream course and also on the slope of the stream and also on the bank of the stream, like that on the other side also. It does not end here, it does not get limited to the bed width of the stream. It has to negotiate the slope as well as the bank for some distance, which we can see now in the other section. Let us study this section. This is a sketch showing the cross section of the stream. That means the water will be flowing in the stream, and this is the cross section, and this is the bed of the stream, and this is the width of the stream, right side slope and left side slope, and this is the bank, rising bank on either side. Now, the structure which we are going to construct would be below the bed level, and as shown here, this is the bedrock profile,